This is ASFurther Maths. We are on Unit 4 looking at vectors, and we're on 4.9 then, the equation of a straight line. So this is a different form of the vector equation then of a straight line. Again, this bit's a bit complicated, but if you look at the example and work your way through it, hopefully it'll make a little bit more sense. If a line is parallel to a vector B, there's our line, and if a point A on the line has position vector A, and any other point R on the line is position vector R, then the equation of a line is R equals A plus lambda B. That's the one that we're used to, where lambda is a scalar parameter. Don't worry about that bit. That's obviously from the textbook. Now the vector AR, how do you get from A to R? Minus A plus R, or if you want then R minus A, where AR is parallel to B. But you learned earlier that if two vectors are parallel, then their vector product is 0. So another form of the equation of a straight line is that the R minus A, which is this bit, cross this equals 0, and that's what we're written there. R minus A cross B equals 0. So find an equation of the straight line which passes through the point A and is parallel to this. We could just sub that in as array under B, and that would be the other form, but we're looking then at the new form. So let's see if we can work out how we're going to find this. So I'm going to take down this sentence. The position vector of A is 2 minus 1, 1. If R is any point on the line, sorry, my light's just gone out there. I'm going to pause, see if I can get it sussed out. Okay, we're back. Is any point on the line then with position vector R, we're going to have then A R is equal to R minus 2 minus 1, 1. So that's our R minus A effectively, because that's our point A, and so R minus A gives us then our vector AR. And we know this is parallel to 1, 4, minus 3, which is where I'm getting this from here. Alright? So that means R minus 2 minus 1, 1 cross 1, 4 minus 3 equals 0. So what we're saying, if two lines are parallel, then their cross product is 0. So we know this one is parallel to this, so we put it to 0. We're now going to multiply this out, so it's going to be R cross 1, 4 minus 3 equals, so I've multiplied this out, effectively multiplying this by this, multiplying this by this, and then I've taken this over to the other side, and that's the cross product then of these two things. So that's 2 minus 1, 1 cross 1, 4, 3. If we do the cross product for this, how do we do that again? Not quite going to do it here, but it's going to be I J K 2 minus 1, 1, 1, 4, it's minus 3 I think, isn't it? And then what that gives us then is minus 179. You can take my word for it. R 1, 4 minus 3 equals minus 179, and is an equation of this line, and is equivalent to R equals the A plus lambda B. So remember our A was 2 minus 1, 1 plus lambda upon 1, 4 minus 3. So this is our new form, r cross this equals this. It's an equation of this line, and it's equivalent then to our old form, which is this.